Okay, good evening. Another session. This is module 7, DHCP version 4, CCNA 2. So I think this protocol DHCP, we got introduced to this in CCNA 1. There's a protocol responsible for automatic address assignment for end devices as well as, let's just say, host in general. Because it can be used to assign addresses automatically to end devices, even interfaces, router interfaces. So that's why I said was in general. Here we go a little bit further, understanding how that happens. What is the process of automatic assignment of addresses, as well as how do you configure a pool? Where are the addresses coming from? There is a pool which is configured on a server. Then every host will get an address from that pool. So I think basically that is what module 7 discusses. I think it's a pretty much small module. Hopefully we can get it done in 2 sessions. At the end, I think I'm also going to do a lab, which is very much basic and simple. Right. Objectives. So we'll explain how DHCP operates in a small to medium-sized business network, configure a router as a server, then configure a router as a client. Right. DHCP assigns addresses automatically, dynamically. Because desktop clients typically make up for the bulk of network nodes, DHCP is an extremely useful and time-saving tool for network administrators. So instead of us having to manually configure every host uh, in a network, you could have quite a number of hosts. So instead of manually configuring every host one by one, I think DHCP is a very much useful tool in allowing us to save time because you have to automatically configure addresses. There is a dedicated server which is scalable and relatively easy to manage. So if you have your pool configured, every time there is a host which needs an IP address, it's very easy to scale. If there is an end device which needs an IP address, then it automatically gets it from the pool instead of you as the administrator having to worry how and when to assign an IP address. Uh, the server dynamically assigns or releases IP addresses from a pool of addresses. I think another important thing to get to understand is, excuse me, assignment of addresses is done in leases, sort of renting. So an address is not assigned permanently to an end device. When we're using DHCP, an address is not assigned permanently. It's a lease. There is a time, specific amount of time an end device, a host is given before that address goes back to the pool or before it another request is made so that the address doesn't respond. So clients have to lease the IP addresses and every other information that comes from the server. So this is just the basic introduction. DHCP dynamically assigning addresses. There is an issue to do with leasing. Advantages with an issue to do with scalability. You can easily scale whilst using DHCP, as well as time saving. It's very useful and time saving. Right. Its operation. DHCP works in a client server mode. I think we'll soon realize that. Client is the host that needs an address, then the server is where the addresses are coming from. So DHCP basically works in a client-server mode. When a client communicates with the server then assigns or releases addresses to that client. The client connects to the network with that leased IPv4 address until the lease expires. The client must contact the server periodically to extend the lease. So I think I've already mentioned this one. The lease mechanism ensures that the client that move or power off do not keep addresses that they no longer need. So I think this is another advantage of leasing addresses instead of permanently assigning addresses. I think when we did CCNA 1, I think it should be the module which had to do with IP addresses, version 4 or version 6. There was an issue with we don't have much of addresses left IPv4. Actually, we've already exhausted IPv4 addresses. So I think this was one of the ways which was very useful in conserving the addresses that are active. If a device is not active, then the lease that it has will expire. That address will then later on be used. So I think that's another advantage of having this list mechanism. Obviously, with the introduction of IPv6, it seems like it doesn't have much relevance, but it still is very useful. When a list expires, the DHCP server retains the address to the pool where it can be reallocated as necessary. Right. Steps to obtaining a list. So we basically have those four steps which are used to explain how a client can obtain a list from a server. So breaking it down, we have basically four messages. What is very useful is understanding how those messages are being sent, either broadcast or unicast. I think when it comes to questions time, it will be very important for you to understand which type of messages is being sent and is it a broadcast or a unicast message. So for the broadcast, four messages that we have with the discover, offer. Let me see if I can have my pointer laser. All right, so we have the discover message, we have the offer message, the request, then we have the acknowledgement. The discover is a broadcast, which is used to broadcast to uh, servers in a network. So there is highlighted, I would like to request an address. So a client broadcast, soon as soon as the end device enters the network or as soon as it's switched on, then it requests an address using a broadcast. So this is broadcast to all devices in the network. To be more specific, it is being targeted to servers in the network. All the servers in the network, they receive that message. Then from there, we have the offer message, which is unicast, which comes from the server, which is basically a response to the request, to the discover message, which is basically a response to the discover message offering an IPv4 address. So the offer, very important, it's a unicast message sent by the server to the client offering the address. Here, there is also some additional information regarding what will be the default gateway, what will be the subnet mask of the network, what will be the DNS server. So the offer not only offers the IP address, but it comes with the gateway, the mask, as well as the DNS server address. Then client responds with the request. So this is another broadcast which is used to accept an IPv4 address offer. All right, so this broadcast will include the IP address that has been offered, and it is sent back to all the servers in the network. So this is basically saying I have this IP address that I've been given. Why is it important? It allows every other server that it's sent in an offer to know that the client they were offering has been offered an IP address. Then obviously we have the acknowledgement with the server which is offered the IP address, acknowledging that its IP address has been taken up. So from the pool of addresses that it had, one of the IP addresses has been taken up. So if you understand this process, uh, if you understand it, you realize it's all done so that we don't have duplicate addresses. All the messaging, especially from request and the acknowledgement, that request message, it's used to prevent having duplicate IP addresses. Because if you don't respond to all the servers in the network, telling them which IP address has been taken, then they'll probably be offering it again to other hosts. In duplicate addresses, they're definitely a problem in a network. So basically, these are the messages that are sent: the discover, offer, request, and acknowledgement. What's important is to take note of the type of the type of is it broadcast or is it unicast? The type of delivery option that we have. I think the last time we discussed this, I had a talk with Lloyd on if a request is a broadcast or a unicast. I think there was also something about an offer. Is it a unicast or is it a broadcast? Uh, I want you to do some research. Those messages can be different depending on the type of rules that are being used. For now, I think for now, let's stick to what is here. But with a little bit of more research, you realize delivery options would differ depending on the type of rules that are being used. So the request, the offer, and the acknowledgement, especially the offer and the acknowledgement, they can be sometimes broadcast. And I'll leave that for research. Right. Step two, renew a lease. Prior to lease expiration, the client begins a two-step process to renew the lease with the DHCP server. Right. So we have just a minute. So before a lease expires, a client can renew that lease. Here we have two specific timers that we have that are very useful. Timer T1 and timer T2. Right, let me use my pen. So we have two timers that are very useful. Timer T1 and timer T2. This one, T1, is when we are at 50% of the original lease. So let's say the lease was for 24 hours. At exactly 12 hours, that's where we have timer 1, which is T1. Then timer T2, this is at 87.5%. Why are these timers important? When we are at T1, that is where our request is sent. We send a request trying to renew the address. So this is at T1 at 50% of the lease. You send a message, the host sends a message trying to renew its IP address. Then if the server responds, the IP address is renewed. If the server does not respond, at T2, we have another message which is sent, which is a DHCP request. But at this point, it is now a broadcast. So at T1, this is a unicast. It is sent to the server which had offered the lease. So at T1, if our time lease was 24 hours, it means at 12 hours, a renewal is sent. The message for renewal is sent. If we don't get a response, what is 87.5? We should be 18 hours. If we don't get a response after 18 hours, then here we send a broadcast. So this one now is sending to all the servers in the network. Just in case one of the servers is down, then we are sending to all the servers in the network, also trying to renew that same address. If we don't get a response, then obviously it expires and we have to discover a new IP address. So the DHCP request, it is used to renew. The unicast is sent at time at T1, then the broadcast is sent at time at T2. If server accepts the renewal, then it sends an acknowledgement acknowledging that it is renewing the lease, and it also sends the information for the renewal of the lease. I think it's also important to note part of the information that is sent even on the offer. We talked of discover, we talked of offer, request, then acknowledgement. So here we say that the offer includes the IP, the subnet, the gateway, the DNS server. Here we also include information on the lease. How much time does the lease has? So that offer also includes that information as well. So in summary, steps to renew, we have the request, which is sent at T1. If not responded at T2, a broadcast request is sent. If not responded, then the lease expires. If responded, the server responds with an acknowledgement, which basically renews the lease. Right, configuring a Cisco iOS DHCP server. So you realize that a router, when you talk of a server, when you talk of a DHCP server, you realize it can actually be a server which its main purpose is actually to dynamically assign IP addresses. That's where you create a pool, or we can use a router, especially for small networks. We can use a router. For larger network, enterprise network, there is a dedicated server which is specifically for that. So for example, here, instead of having a DNS server, in large networks, you can have a DHCP server. So this one is dedicated specifically for that. It allows, I think, logically the router to perform other functions besides dynamically assigning addresses. However, for small networks, the router can be used as a server. So this is just an introduction to that. Router can be used as a server. If we are configuring a router as a server, we have a couple of steps that we have. Step number one, we exclude addresses that are to be used from the pool. So for example, addresses that are to be assigned on the interfaces of the router, manually assigned, those addresses are excluded from the pool. Addresses that are assigned manually, especially for servers, it's not recommended to assign addresses dynamically on servers, because you need to know those addresses. Those addresses will need to be static, manually assigned. So they are also excluded from the pool. So the pool, step number one, is basically excluding addresses for statically or manually configured addresses. So the command, I think we'll do a lab. That's the command ipdhcp exclude addresses. You have the low address, you have the high address. So for example, if you want to, I think there's an example right here. This is the example we have. If you want to exclude addresses from .1 to .9, this is how you do it basically. So this is the low address, this is the high address. If you want to exclude a range of IP addresses, you can see with this second command, you can also exclude just one address. So it's not only a range of IP addresses that you can exclude, you can as well exclude just one address. So that's it for addresses excluded. Then step number 2, you define the pool. Define the pool name. Command DHCP pool, then you enter the pool name. After that, you enter the DHCP configuration mode where you can further configure the settings of your pool. Right, step number 2 leads us to step number 3, where we enter the configuration mode, the DHCP configuration mode, and where we have to define the settings of our pool. What do we define with the pool? You define, number 1, the address. What is the address which we are going to be getting our addresses from? So in this example, you can see from this network, we have this network. All addresses in this line are going to be coming from this network. So that is the network you configure on the network command, telling the server which network is going to be used as the pool. Now, the excluded addresses obviously belong to this pool, but they will not be assigned to any devices because they've been excluded. So the pool, the network command, this one, basically tells the server which network to use for the pool. Then from there, we go to the default gateway. The default gateway, when I said the offer message, it includes the IP address, the default gateway, the subnet, the DNS server. Every host that is using DHCP will need to know what is the default gateway. And how does it know? It knows because the server defines the default gateway. So every time an offer is sent from the server, it will include the default gateway. Then from there, we have the DNS server. The offer will also include the DNS server. Therefore, you need to define it on the router. You need to define the domain name. You need to define the lease, the duration of the lease. Then we have the NetBIOS server. So I think everything else is pretty much clear, except probably for this. I don't think we did anything to do with NetBIOS. This is no longer used that much. NetBIOS, this is a uh, legacy protocol that is used to map, I think it should be IP addresses to, is it to domain names? No. I'm forgetting the name. Let me see. Right. The same way we have DNS, which is used to map domain name servers to IP addresses. We also have this NetBIOS, which is used to map IP addresses to NetBIOS names. This is no longer relevant, this one. We no longer use it. It was actually replaced by DNS. Not sure why it's still here. So NetBIOS, same function is being done by DNS. This is a legacy. This is a legacy service there. So duration, domain name, DNS server, gateway, define the address pool. I think we pretty much got step 3. Then the example, this is the example we are going to be doing for our lab. Exactly this one. We're going to configure a network. We're going to define pools. So we define this pool and this pool. Then the pools will respectively assign addresses to this PC and this one. All right, verification commands with the show running, section DHCP, show IP, DHCP binding, show IP, DHCP server statistics. So the running config, right, this is the running config. The running config basically shows us, as you can see, this is what we just configured. The excluded addresses, this is another excluded address. This is our pool name, network, default gateway, server, domain name. So if you want to verify what you've configured, you can use the show run configuration, then use the keys to jump to keyword section in DHCP, and you get this information. If you use the bindings, show IP DHCP bindings, it will show you the IP addresses map to the MAC addresses, the physical addresses, and the IP addresses. For every host, what IP address is binded to its MAC address. So this is what it gives us. It's another way of verifying if one DHCP is functional and what is the map of all the bindings that has been made. Then lastly, we have the statistics, which is also used to verify if DHCP is functional. So this one, it gives us the total of all the messages that are being sent or received by the router. So you can see here, we have an address pool that has been, one address pool that has been configured. You can see we have 4 discover messages, 2 requests made, basically showing us DHCP is functional. So statistics just gives us a summary of all the messages that are being sent between the client and the server. All right. We also have the ipconfig command, ipconfig/o actually. ipconfig/o, this is used on Windows host to verify as well the addresses that have been dynamically assigned or statically assigned to a device. So if you go to our Windows host ipconfig, or you can see this is the domain name that has been assigned dynamically, the address that has been assigned, the default gateway, and the servers. So the ipconfig, or I think is very important to verify the address assignment on a Windows host. Right. Disabling the Cisco iOS DHCP server. By default, DHCP is enabled. Sometimes, if you want to disable, it's a very simple process. No service DHCP. So if you want to disable DHCP, just use the no service DHCP. We also have things to do with clearing, bindings, stopping, or restarting the DHCP server. It has its own consequences. What are those consequences? Right? If you clear the DHCP bindings, well, the bindings gives us the IP address. The MAC addresses binded to the IP addresses. So if you clear that, the consequences are duplication. Why? Because you will clear the bindings. However, it doesn't mean you have removed the IP addresses from those bindings. When you clear my bindings, what it basically means, you've cleared the IP address, meaning this IP address goes back to the pool. However, it is still assigned to that specific host. It goes back to the pool, but it is still assigned. So clearing the bindings, it leads to duplication because address inodzokera kupool, but on the device is still using that address even if you've cleared. So clearing bindings danger. It leads mostly to duplication because an address inodzokera kupool. Right, and basically this is it, disabling. Then we go to the relay. In a complex network, enterprise servers are usually located centrally. Servers may provide DHCP, DNS, TFTP, FTP services. Clients are not typically on the same subnet as those servers in order to locate the servers and receive services. Right. In small networks, we don't have a problem with having servers that are located centrally. I think I touched on this briefly when I said small networks. This acts as our server, the router. For large networks, this is used specifically for routing. All its processes, routing. What it means is we need a server that is somewhere. So here we have our DHCP server. So for this PC here, for it to get an address, it will need to communicate with this server here. However, that server is not on the same network, different subnets. It either cannot be on the same subnet or it can not be on the same VLAN. For reasons that we discussed when you did VLANs, when you did network segmentation. When we did network segmentation, we talked of security. We talked of performance. For those specific reasons, that is why a server and a client are not on the same network. Problem is now, when you want to use DHCP uses broadcast. When you send your discover message, this is a broadcast. So if PC1 sends a broadcast, that broadcast is confined within this network because routers do not forward broadcasts. So how then does PC1, the client, communicate with the server? The how part is addressed by the router acting as a relay. So the router acts as a relay with a couple of configurations that are made, which allows this router, if a broadcast is sent to this router, then the router will send a broadcast to this server. In this case, we have the router forwarding broadcast via the relay. By default, I repeat, by default, routers do not forward broadcast. However, with the function of the relay command, the router is then able to forward a broadcast. So that's basically the idea behind DHCP relays, where we are not able to send broadcasts in large networks usually. From the start, we have large networks. The server and the client are on separate networks. Broadcasts cannot be forwarded by the router. Therefore, the router will need to be configured as a relay. How do we do that? We go to the interface which is facing your local area network. Then you configure the IP helper address, specifying this is the address of the server. So every time there is a broadcast which is sent from a client, then the router will act as a relay and forward the broadcast to the server. And basically, That is how a relay works. Relaying is not only useful for DHCP time. I'm sure that should be NTP time. All devices will need to be synchronized. How are they synchronized? Broadcast time, NTP. I'm sure this should be NTP. Port 37, it should be protocol NTP. So they also make use of the relay function to broadcast messages to every device in the network. Uh, TACACS, this is to do with it should be authentication, authorization. I don't think it is accounting. Then DNS, we know this. DHCP, we know this. TFTP, we know this. NetBIOS, NetBIOS, we no longer use that much. So basically, here we have the relay function not only being used for DHCP, but being very useful as well in some of those protocols highlighted. Configuring a client. Right, we've gone through how we configure a server. All right, I'm looking at my time, less than 1 minute. I think one more session will be enough to complete this one. Join me using the same link.